Welcome to the last chapter of Pure 2, chapter 10, which will look at the modeling part of the Newton-Raphson, approximating roots, etc. Chapter. We know how Exambot loves modeling. It's almost like their childhood dream. It's all about modeling, going on the fashion show, but they couldn't. So that's what they do to torture us. Anyway, the notes. So we can apply same skills to estimate solutions in real life situation models. Example, the price of a car in pounds X years later after purchase is modeled by this function f of x equals that. So in the modeling question, again, first thing is you need to think about what are the variables and what do they stand for. So the variables are f of x, so which is the pounds, and the x, which is time, right, in years. So whenever we see years or pounds, then we know which one we can substitute into. Okay, pi, use the model to find the value to nearest £100. That means we want to find f of x because we know pounds is the unit for f of x of the car 10 years after purchase. So question A, when x equals 10, easy peasy. So let's sub it in. So f of x equals 15,000 times 0.85 to the power of 10 minus 1,000 sine 10. Now you might be wondering, do we use radians or do you use degrees? Now the question is, actually, I will put both in the calculator, see which one makes sense. If I try to put radians in the calculator, which I'm already in, so if I try to put radian in the calculator, I get 3,500 roughly, because they want to route to nearest 100, 3,497. So in radians, I get 3,500. What happens if it's degrees? So let's try that. In degrees, I get 2,779. Now, I believe all the modeling question in modeling question with trigonometry should be in radians. Okay, should be in radians. So in radians, you get around 5,000. So you should get 3,500. Now this in radians. Okay, so yeah, so in a modeling question with trigonometry, I would suggest using radians unless they tell you in degrees. Okay, that's how I see it. Part B, show that f of x has a root between 19 and 20. Method we have to use. Guess what? Sign changes. Okay, so we'll do f19. So put 19 to calculator, you get 543, and put 20 in the calculator, you get negative 331. So we can wrap it up, sign changes. Therefore, there's a root between 19 and 20. Okay, simple, easy peasy. Part C, find f dash x. Okay, we love it. Differentiate. So, I'll let you think about, you can pause video, differentiate yourself, and see if your answer match up with mine. So 15,000 is the same. Differentiate 0.85x to the power of x. It's the same as a to the power of x times ln a. So I'm not sure if you remember this. Okay, it's a derivative. This one is to differentiate a to the power of x, the derivative a to the power of x ln a. Okay, and then minus differentiate sine x is cos x. Differentiate sine x is cos x, so 1,000 cos x. Okay. Part D. Taking 19.5 as a first approximation, okay, use Newton-Raphson once. So Newton-Raphson tells me to xn plus 1 equals, so I will do x1. So it means x0 is 19.5. So x1 equals 19.5 minus f of 19.5 over f dash 19.5. So you should be substituting in numerator, you should be substituting 19.5 into f of x into original, and denominator you should substitute 19.5 into the answer in part C. So you put in the calculator, they want you to do it once. Do it once. What is it? Apply once. And give your answer 3 decimal places. So you should get 19.528 in 3 dp. Okay. Criticize this model with respect to the value of the car as it gets older. Well, as it gets older, think about when x time, in here they use x as time. When x get a big value, what happened in here? Actually, that's negative. So when x equals 20, it's negative value, but we know the car cannot be negative value. Imagine that, negative value. That means when you have to scrap the car, not only have to pay for that, not only when you sell the car, you have to pay the buyer money. I'm selling the car to you, yes, but I have to pay you money. Just imagine that. Impossible. So F20, okay, since F20 equals negative 331, um, but the price of the car can never be negative. Therefore, model is not valid after 19 years. Okay. Right, next one. Pause the video. It's a practice. Okay, pause video, have a go at a question. Okay, in power physics, so you can't blame me. It's in radians, definitely radians. Okay, pause video, have a go at a question. When you're ready for the answer, you can press play. Now, I know you might be struggling in part A. Essentially, part A, they give you two equations. Okay, m equals e minus 0.1 sine e, and m equals pi over 6. I just make them equal and rearrange it, make it equal 0. Because I know if I want to use Newton-Raphson, if I look at part B, I need to use Newton-Raphson. I know one side has to equal 0 for it to be make it into f of x. Therefore, I rearrange it and I realize I look at the question. It's quite similar. It might look quite confusing what you should do. However, if you now you should know what to do. Okay, and k equals pi over 6. Because if you try to compare my f of x into their equation, you see that's f of x. Once you're happy with this, okay, you've got the equation to start with. You can do part B and hopefully part C as well. So here's the answer. Now f of x, I think I did make it slightly confusing where f of x, this is actually not f of x. So what's the difference between e and f of x? Well, e is actually a root. So when we write it, f of x, actually we can replace e with x because e is just a root. So x equals, or you just basically use the question, use the question from the equation from the question. So yeah, okay, you can almost ignore the context of a question really, but you can see how these kind of maths could be included in some difficult maths. Obviously, they're making the model very simple. Newton-Raphson, so f of x equals that one. So and differentiate it, and then x0 equals 0.6. Make sure you use the calculator in radians. If you don't use the radians, you get something similar, but actually not the same answer. But using radians, 0.578 to 3 decimal places. And then to use sign changes method, upper bound, lower bound, sign changes. So you have to write a root, correct to 3 decimal place. And that's the end for chapter 10, really. I would say quite a weird chapter between differentiation and integration. But here we go.